Hello grade 12s, welcome to my channel. So it's time now folks for the revision for term 1 exams, and I hope all the basics have settled in and you guys can see when to use them even if you're not told. And yes, I'm still going to continue to show you some of these because they become critical as you go along. So we're just gonna keep doing, bit of basics every now and then we do some, more structured questions which may apply those basics. So folks, please get ready. A bit of time attack at this point would be important as well to practice so that you guys can make sure by the time you do this exam, the term 1 exam, you are able to finish writing. At the same time, you just reserve some time to do checks and to make sure everything is going accordingly. Now folks, I'm probably going to do 2 videos for this purpose. So we're going to start with this paper from the Eastern Cape. This was from Amatole East District. Okay, please folks, stop this thing of saying Amatole when you're speaking in English. It doesn't change the name because you're speaking in English. It's Amatole. So the stress and intonation there on the syllables is down. Okay, it's not going up. So don't change it. Okay. And again, folks, we don't just name places for fun. There's usually an implication to that. For example, if you think about Amatole, which is calves or the young of cattle, what do we know about them? These guys are very vibrant. They are good looking, especially when well fed. They are flexible. The more important thing about them is that they grow into something bigger and better. Because once they become full cattle, what do? They provide us more cattle. They can give us meat. They can give us milk. Even their skins can be used for a lot of other things. So technically, the name itself is suggesting that this is a very vibrant, energetic, and perhaps flexible district which is continuously growing into something bigger and better. I hope this is the case. And of course, we ditch these nonsenses of just changing names of places for the sake of changing. But if you look at the name, there's no meaning to it. Take PE, Gqeberha. What does that mean? East London is now called Kukombo. What is that? Crazy. Anyway, folks, let's leave that to those who really cherish absolute rubbish. And what can we do? There's plenty of them. They are more than those who are sensible, so we can't do anything about it. Right, instructions, folks, they are very important. It is the grand instruction, if you will. This tells us to read the following instructions carefully before answering the questions. And of course, the first one tells us how many questions we've got. But you see, we have to answer all the questions. Now, a student may sit back and be like, what is the use of this instruction? We know that these provincial papers are notorious for mistakes. And as a result, students may need to be given marks. But remember, if you did not attempt the question, you don't get those marks that are given to those who will get those marks. Okay, sometimes these are some of the things that sink your great mark that you could have got, but because of not adhering to instructions, you end up losing those marks. Now, this is one of the main ones. Exactly, for calculation based questions, if we used diagrams, we used graphs, we used anything that is applicable. The emphasis is on this one essentially because you often ignore these theorems, axioms, you name them. If you have used it to determine the answer, please do show that you actually have. Right. Of course, folks, we read and read and read. Now, the other main one is the issue of rounding off. Can you see? 2 decimal places, no more, no less. Okay? Very important. And of course, folks, answers may, not will. The best word to use here is may not necessarily be awarded full marks, because we know there are questions and functions when we do graph interpretations. There is no need to show how you did it. the matter is the answer. So an answer only gets full marks. So to say answers only will not, this is almost like saying if you ever give an answer only, you're not going to get marks, and that's not the case. They may not give you full marks, because if the question is clear as to what it requires from you, you cannot just present an answer only. Of course, you will get used to this as we go along. And of course, we number questions correctly. I've seen students write everything right, but now give an incorrect label, as in the question number, and that unfortunately is punishable. And of course, folks, be as neat as possible. When you scratch something, don't do this thing, okay? It's not acceptable. Just draw one line through it. Just a single strike is good enough to indicate that you are canceling that. And of course, issue of legibility, folks. It means whatever you write, we must be able to read it, okay? So that's the most important, so that you are not misunderstood, or at least you don't make it too difficult for your marker to follow your work, right? Now we've got question 1. Now question 1 is already jumping into sequences and series. Now I have a problem with a maths paper that does not have algebra, especially for grade 12s. We need these higher order type of questions in algebra. Now, there are some big-headed people with small shoulders and small legs who go around saying, you don't need to understand the subject, because you know what, you're never going to use it on your daily living, or even when you become, say for example, you choose a career in the medical field, or should we say in health sciences. Now you'll be told that you're never going to solve for x there, so why must you solve for x now? It's only because those folks seem to not understand that in life you are not taught so that you can regurgitate. You are taught so that you can utilize whenever the need arises. You don't need to be told that you have to do that. So people who say those things are people who only wait to be told, actually, you can solve it this way. Actually, you can apply algebraic techniques of solving for the variable x. But again, folks, why should you be told something you've been doing for at least 3 years? Now, in the 4th year, when you need to apply this, you wait until you are told. Then it says something about you. You are somewhat not someone who's educatable, if there's such a word. You are not educatable, because if we're going to tell you everything, then it means we are the ones actually doing it for ourselves through you. So there's no sense of spontaneity on your part. Anyway, folks, I want to make an example why algebra is such an important thing. Even one of my family members told me this when I was still in high school, that you're busy solving x and y, but I've never used it as a health professional. So what's the point? So yes, there are many benefits, but let me just show you a direct one. Say for example, we have a 5 kilogram baby, right? The baby is unwell. Now we need to give a medication for a lower respiratory tract infection. So we've got penicillin on our drug cupboard. So this is, of course, an antibacterial medication. Now, the medication in the manner that we have it is such that we've got a vial of 10 milliliters, which contains 10 milligrams of the drug, okay, the active ingredient. And of course, if you read the leaflet or the pamphlet that comes with the packaging, it tells us that for a pediatric patient or a small baby, we must give 1,2 milligrams per kilogram per day in 3 divided doses. Okay, doses. So that's the instruction on the leaflet. Okay. Now you are a nurse or a doctor who wants to administer this medication, or at least wants to write a prescription. So how would you get this done? Because we often dose medication per weight to avoid issues, because we know that from our research, certain weights of babies can handle, certain amounts of the drug in a particular way. But now the main issue is when these people actually end up with drug reactions. For example, they are hypersensitive to a certain medication. Now you need to be able to predict how the body is going to handle that medication, right? And as well as what that medication can do to the body and for how long. Now this is when we talk pharmacokinetics and dynamics. Now, essentially, we can only give supportive treatment to the patient sometimes because there's no antidote, but hoping that after a short period of time that is predictable, that medication will have worn out of the system or gone out of the system. And then we can accept, or at least expect normality. So this is the push to this. Now I want to show you where algebra comes in, even arithmetic for that matter. Now folks, you as a clinician, you want to sort things out. So you know that, okay, you want to know what is the maximum daily dose. The maximum daily dose is going to be 5 kilograms, right, multiplied by the recommended dosing per day. So this is 5 times 1,2. This, I know 5 times 1 is 5, 5 times 0,2 is 1. So 5 plus 1, that's 6 milligrams, right? But now in divided doses, this is going to be 6 divided by 3, which is going to give us 2 milligrams. So these are, what can you say, equal injections of 2 milligrams 3 times a day. Now this is, sometimes we call it 8 hourly, because if you say 24 hours divided by 3 in terms of hours, if you want to know the dosing intervals, so this is going to be 8 hourly. Sometimes you see this TDS on the scripts, okay? So it means 3 times a day, or 8 hourly. So this means every 8 hours, we are going to give 2 milligrams. This is the maximum daily dose. So can you see, folks, we have a nice question here. Now the question is, we are given a vial that contains 10 mils instead. So how do we get 2 mils? Of course, a quick student would know that this would essentially amount to just 2 mils, but let's say it's not so obvious, or at least you don't understand what's going on. Instead of giving an incorrect dose, you can say, okay, I know that 10 mils gives essentially 10 milligrams of the drug. Now, how many mils is going to give me 2 milligrams, which is what I want, so that every 8 hours I give that amount of mils from that 10 mil vial, okay? So, of course, we cross multiply, folks. As you can see, these are all arithmetic algebraic techniques. Right, so x times 10 is going to give us 10x, just drop the units. 2 times 10, that's 20. And so we know that x is going to be just 2 mils. Remember, this is the mils. So this means from our 10 mil vial, we're going to take 2 mils, which is going to be an equivalent of 2 milligrams of the drug, which is what we need. And of course, we're giving it 8 hourly, or you can say TDS, or 3 times a day. So can you see, folks, this is an algebraic calculation. Now, if you take this a bit more, say, how did I know I'm going to get 6? Remember, 5 times 1,2 is nothing but 1,2. We can split it to 1 plus 0,2. Can you see? Then we apply distributive law or FOIL method, and it takes us exactly to the answer that we got. Can you see? You cannot go around people saying things you don't know. In fact, just be honest with yourselves. When you don't know, just say, don't know yet. Perhaps you might find out later on, or you may be intending to find out. But don't say there is no such a thing. My family member said this as well, and when I found out, I was like, but you see, the poison that we can spew without noticing. So again, folks, this also says to you all who listen to any voice that speaks, be very selective of the things you take, especially when things sound too good to be true. Anyway, folks, that's why I'm saying algebra is very important as well as arithmetic. As you can see, to now find out how much we should give our patient safely, we had to perform an algebraic calculation. Sometimes you may need to do this with your head without a calculator. That's again the emphasis of saying calculate this without using a calculator, so that you get used to doing this even when the electronics fail you. Anyway, folks, that was just me trying to show you that algebra is not something to be ignored, all in the name that if you want to become a doctor, you're just going to cram your way through. You're going to be a dangerous doctor, believe me. There's plenty of those already in the system who just crammed their way and they never know what's right. Unless they get lucky, or at least they treat someone who's going to be well anyway. Because there are such situations, you find that someone is sick, but they're going to be okay even if they didn't get medication. Perhaps the doctor even missed the entire point. I see patients coming into the hospital with a particular complaint. A doctor just orders an investigation, and based on what they find, which sometimes may be an incidental finding, then they start focusing on the incidental finding, and they don't treat the problem. As a result, someone ends up complicating in the future. Or if it is cancer, it ends up spreading because nobody thinks before they act. They just act because, you know what, this is what is common. Okay, anyway, folks, that's it. It's just the frustration I have, and I'm just sharing with you that please don't be ignorant. Even if you're hearing some smart people or those you suppose are smart saying ridiculous things, be able to see the lies from the truth. Sometimes be inquisitive yourself. Don't just be complacent. Anyway, 1.1, we are given a quadratic pattern. Now, this is a grade 11 question, to be honest, but we may have a grade 12 type question. Let's see, minus 80, minus 60, minus 48. So this is the quadratic sequence. And we've got minus 80 as our first term, minus 63 as our second term, minus 48, and it continues. Okay, right, so we're told to write down the next two terms. Now, this is not a question, honestly, guys. We should be asking grade 12s. This is ridiculous. This is for grade 11s, not grade 12. Look, they've already passed grade 11. Why are we still examining them in the grade 11 sense? What's the use? Anyway, folks, to get those two terms, we can use this and say minus. So now we've got minus 63. So we want to know the first difference, okay, between those two. Now, what are we going to do? We just say minus 63 minus minus 80, which is just going to be plus 80. And what does it give us? Ayman, come on, tablet. Don't do this. Don't do this. This is 17, okay? And then, let's see. Now, we're going to have minus 48, right? Minus 63. That's just going to be plus 63. It gives us 15. Now that we know this is a quadratic sequence, we don't need the fourth term. We know that the difference between these two is going to be common. So 15 minus 17 is minus 2. Now, we know, folks, that essentially, if we take these, if we take those together and we just add them up, let's do it. 15 minus 2 minus 48, it gives us minus 35. Okay? And then we need the next one from there. So we know, folks, that okay, all right, okay. The one thing that we can see is going to happen here. We can either take the difference between these two, right? And see what that is. So minus 35 plus 48 gives us 13. The other way, you would just say 15 minus 2, because every time we're just subtracting 2. So this is what we have, okay guys? And of course we know that between these two we're gonna have essentially minus 2. And we can do the same thing, add this up, and when we do that we're gonna have 13 minus 2, that's 11. 11 minus 35 is going to give us minus 24. Okay, and the sequence continues. So to answer 1.1.1, what is it? We know that T4 is minus 35 and T5 is minus 24. That's it. So we're getting 1 mark for the both of them. So 1.1.2. We now have to determine the general term. Again, this is a grade 11 question. It should not be here. So we know that 2a is equal to minus 2. So this implies that a is going to be minus 1, which will also imply that 3 into a, which is minus 1, plus b is going to be the very first difference. Therefore, our b is going to be 20, right? And we go on and say this would also tell us that a, which is minus 1, plus b, which is 20, plus c, should be the very first term of our quadratic sequence. Therefore, c is, now this is going to be 19. When you put it across, it's going to be minus 99. So therefore, our t sub n is going to be minus n squared plus 20n minus 99. Great. Very easy. But please, folks, when you get to this step, check if this is good for the sequence. There has been a situation where we've got some coincidences happening. Now let's see. We get a mark for each one of these guys. That's essentially the thing. This is putting them together. We have to earn those 3 marks, but we don't earn the last mark for the final answer. Okay, sometimes it's given, sometimes it's not. But again, as I said, it's a grade 11 question. There shouldn't be any issues. Now, folks, let's just check non-contiguous terms. Let's say term 2, for example. So minus into 2 squared plus 20 into 2 minus 99 gives us minus 63. So that's good. Let's jump and say, what about T5? When I say non-contiguous, I don't want terms that follow each other, because this can lead to some, errors that may actually give you the indication that this is correct. Can you see we get minus 24? So there's no way that this is incorrect. Okay, so we are now happy. We move on. 1.1.3 says, between which 2 consecutive terms. Now this is a grade 12 question that we should ask, and it's fairly a standard grade. Okay, between which 2 consecutive terms of the quadratic pattern will the first difference be 103? Even grade 11s would qualify as a higher grade question for grade 11s, but this is a standard grade question for grade 12s. Now if we just observe something here, we will see that, look, T2 of the first differences is in between T2 and T3 of the quadratic pattern. So can you see there is somewhat a positional relationship, if you will, between those two. So this means we can use our sequence of first differences as a way forward. So we know that, okay, T sub n is A plus n minus 1 times D. I showed you guys how to get this formula, how to derive it. So we now know that technically we want to know this minus 103 because that's the one, isn't it? Is equal to A is 17 for the first differences plus n minus 1. That's what we want. D is the constant second difference. So essentially we just go on and do the things. So we can say minus 103 equals, so when we multiply, here's going to be plus 2, so this is going to be 19 minus 2n, and then this implies we move this 2n to this side. It's going to be equal to 19 plus 103 gives us 122, right? So therefore n is going to be 61. Right, so this means in the first differences, minus 103 is term number 61. So what do we know? We can say therefore 103 minus 103 is the difference between term 61 and term 62, the one ahead. So this is as easy as ABC. Of course, there are other ways of doing this, but I did show you guys the issues with that technique. If not well executed, it can lead to a disaster, but if well executed, it actually can answer the question very easily. Okay, so that's essentially how we solve this problem. So of course substitutions into this is good, and then answering the question is good, and we can say perhaps knowing that this is what we're looking for, that's somewhat enough for 3 marks. Okay, good. Now let's do 1.2. 1.2 says consider the following sequence. So there it is, and P is not to be equal to 3. Why? Because if we focus on the brackets, we will appreciate that if that becomes 0 when P is 3, then we don't have a sequence. There's nothing. So we can see that the restriction is harmless except maintaining the sequence. Alright, so there's no problem. So it says for which values of P will the series converge? Again, seeing exponents or ordinals in the sequence is already suggestive that we might be dealing with a geometric sequence. Now, only a geometric sequence can converge, okay, not an arithmetic. So we know that, okay, this must be geometric, and if it is geometric, we need the common ratio. Alright, so we know that, folks, 1.2.1, we know that we know that for convergence, it should be such that R is less than 1, greater than minus 1, isn't it? And then this implies that what is R over here? Now, obviously, this is going to be this term divided by that term. So we know that 8 divided by 16 is going to be a half into, now that bracket divided by that just leaves one of that bracket. It's going to be P minus 3 to the exponent 1. So now we're saying this must be less than 1, greater than minus 1. Now this is a grade 10 inequality type question. So cross multiply the 2 on both sides, we get minus 2 is less than P minus 3 less than 2. Because we're multiplying by a positive number, the inequality signs don't change. Then we transpose 3. When we transpose it to this side, we get 1 less than P, which is also less than. Transpose there, we get 5. Now these are the values of P that will give us what we want. When we transpose, there's no change in the inequality. So it's very important, folks. Can you see we're using a fact to get our solutions sorted? We don't just jump in. So we're getting 3 marks. So of course, substitutions and finding the actual value of r in the final answer. That's good. Or one can say 2 marks for the answer and 1 mark for finding the value of the common ratio. Very easy otherwise. Okay, so we've got 1.2.2. This one says we need to find the sum to infinity if p is 3,5. Okay, so that's easy. We know that sum to infinity is going to be a over 1 minus r. Right, so this implies that our sum to infinity is going to be a is 16 into p, it's 3,5 minus 3, all divided by 1 minus, our r is a half of p, which is 3,5 minus 3. Okay, so therefore our sum to infinity is, let's just put it on the calculator and not stress ourselves. Sorry guys, I forgot, a is cubed. That is cubed. Okay, don't make that mistake. You see, everything can go well, but you find that you're making a mistake. 3,5 minus 3 is nothing but 0,5 cubed divided by 1 minus 0,5 into 0,5 essentially. So we get an answer of 8/3. So this means this series or sequence will converge at 8/3. Okay, usually this is just substitutions and answer. Easy 2 marks, and of course we can appreciate that this was a very easy first 12 marks to score. And of course guys, if you look at all of these questions of question 1, I did show students in a video on sequences and series. So for those who actually watched, and not just watched but learned, they definitely had an advantage here. So we've got question 2. Now question 2 tells us that the sum of the first n terms of an arithmetic series is given by this formula. Okay, now again, if you look at this question, I featured this on that video. So those who paid attention, again, another advantage. Okay, so what is the story? We need to determine the first 3 terms of the series. Okay, so let's see. 2.1, we know that s sub n is 4n squared plus 6n. Okay, now we've got 2.1.1. We now have to find the first 3 terms. We know, folks, that term 1 is going to be equal to s1, right? So I'm just going to rush in and say it's going to be 4 into 1 squared plus 6 into 1, which is equal to, this is 4 plus 6, that's 10, right? And then T2 is going to be, now just note that here we know that T sub n is going to be Sn minus 1. That's the formula I showed. So that's just the concept right here. So it's going to be S2 minus S1. So this is going to be, 4 into 2 squared plus 6 into 2 minus 10. What is that? So let's see. So that's going to be 4, 16 plus 12. 16 plus 12, that's 28. Minus 10, that's 18. Okay guys, so that's T2. So let's see T3. I mean, we can do T3 by inspection. We can already see we were told this is arithmetic. So the common difference here is 8, isn't it? So 18 plus 8 is going to be 26. There's no need to calculate the last one. Okay, folks, so this is as easy as that. And for me, this should be a mark, this should be a mark, and that should be a mark. I don't understand why this is 2 marks. Sometimes these examiners, they will amaze you. Give more marks above for a question that doesn't warrant that, and a question that actually warrants more marks, they give less. And this is not one of those questions that are impossible to say you're trying not to fail students if they cannot manage it. Anyway, let's move on. So we've got 2.1.2. Now we need to, well, we are told that the last term is 58. So we want to know how many terms. Again, this question, guys, perhaps is valid. But this question for me is a grade 11 question, grade 10 question. It should not be asked in grade 12. And imagine 3 marks for such an easy question. Anyway, we know that T sub n is A plus n minus 1 times D. Now, this is 58 equals A is 10 plus n minus 1, D is 8. Right, we go on. So this is 58 equals, now this is 10 minus 8, which is 2 plus 8n. So this implies also that 8n is equal to 56. Therefore, n is going to be 56 divided by 8 is 7. So what is the question? How many terms are there? You can say, therefore, there are 7 terms in the series. Always attempt to answer the question, although a calculation may be good enough, but just show that that means to an end is not the end in itself, okay? Right, so this is very easy. Again, substitutions, final answer, and knowing the common ratio, the common difference. So, okay, 3 marks is fine, I suppose. But I think 2 marks was good enough here. Let's move on. So we've got 2.2. 2.2 tells us that the sum of the first 5 terms of a convergent geometric series is 62, okay? And the sum to infinity is 64. Now we must find the common ratio. Okay, that's easy. Now this is also a good grade 12 question. It involves simultaneous equations. By grade 12, guys, a student should be able to derive equations from word problems and then perform the necessary gymnastics to the answer. Okay, so let's see. We are told here that A, remember in a geometric series, the first term is A plus AR, that's the second term, plus AR squared, that's the third term, plus AR cubed, fourth term, plus AR to the 4. This is equal to 62. Okay. Well, you can make this one equation 1. And then we are told that the sum to infinity, also we know that sum to infinity, which is going to be A over 1 minus R, is equal to 64. Okay, cross multiply here. We can see that if we do that, what happens is that A is going to be 64 into 1 minus R. Can make this equation 2. Now what we want is to put 2 into 1. Let's see what happens. Now we can already see that this 64 into 1 minus R is going to replace a, but I don't like the way that situation looks. We can say a here is going to be 64 into 1 minus r, and then into, we have factored a out, so this is just going to be r, it's going to be 1 plus r squared plus r cubed plus r to the exponent 4. This must be equal to 62. I just factored a out to avoid a situation where I end up with too many, long terms, because this must be before every r. Now I'm going to run out of space. Now, folks, we can already do the things that we need to do. And what are these things that we need to do? We can divide by 64 to get rid of that. So what we end up with is 1 minus r into 1 plus r squared plus r cubed plus r to the 4 equal to, this is going to be 62 divided by 64. That's going to be 31. That's going to be 31 over 32. Right? Now, what are we going to do, folks? We just FOIL it out, isn't it? There's nothing you can do. FOIL or you distribute. Don't be afraid of these things. Sometimes they will look scary, but you just do your thing. Don't panic. Do not panic, students. There's no benefit in being cowards. Right, when we multiply that by 1, we get 1 minus r. Plus, when we multiply that into r, we get 1 minus r squared. Right? Plus, when we multiply that one to r squared, we get 1 minus r cubed. Right? Right. And then when we multiply this one to, let me see, when we multiply that one to r cubed, we're going to get plus 1 minus r to the exponent 4, right? And then when we sort that out, what do we end up with? Did I do the right thing here? I've got 1. I was expecting some things to get out of the way, but I'm not seeing it. I am not seeing it, but let's see. So this is going to be 1 minus r to the exponent 5 equals 31 over 32. Okay? Right, so what do we see there? So we've got, oops, I didn't write this one properly. Okay, now that's it. Now we've got 1 plus 1 plus 1 plus 1 plus 1. How many? 1, 2, 3, 4, 5. So we've got 5, right? And then my problem now is that our r is not doing the r things. What happened? Did I miss something? Did I or did I not? Oh yeah, I did an incorrect FOIL method. Yeah, I can see something is not making sense here. Right, so remember, this 1 times 1 is going to be 1 minus r, plus. Now r distributes to 1, it's going to be 1. It's going to be r minus r squared, yes. Now that's correct, plus. This 1 to r squared is going to be r squared minus r cubed, yeah. The third one is going to be plus r cubed minus r to the 4. Plus the 4 is going to be r to the 4 minus r to the 5. Now that makes sense. So we've got minus r plus r minus r squared plus r squared. Like that, like that. So now what do we have, guys, left? We have 1 minus r to the exponent 5 equals 31 over 32. Now we can move r to the 5 to the one side. Then we take this from 32. So this is going to be 32 minus 31, which is 1 over 32. Okay, let's just continue on this side. So we know that this implies that r to the 5 is equal to a half all to the exponent 5. Therefore, our r is a half. Nice and easy. Okay, so yeah, I kind of did an incorrect foiling there. Of course, you can see that this is somewhat dangerous if you're not careful. Otherwise, it is done. It is done, guys. How many marks? 4. So we'll definitely get a mark for this and for this representation. I think that's good. And perhaps for our troubles here, the 3rd mark. And we can just say the substitution into the other 4 marks. But I think deriving these equations should have been a 5th mark. There is quite a lot, and it really is sensible to do so. Of course, guys, there's nothing wrong with those who want to use the sum formula for the first equation and then the sum to infinity for the second equation. You would end up with the same answer. Okay, you would end up with the same answer. Perhaps let's show you guys, because I know it's easy to talk about these things and then sometimes students don't see these. Sometimes you can say Sn is equal to 62. Now the sum here is a into 1 minus r to the n. But now we're told these are 5 terms, so this is going to be r to the exponent 5. The reason for choosing this formula is because I am told that there is a sum to infinity, so it means r is less than 1. So this is 1 minus r equals 62. So we can safely say, therefore, a into 1 minus r to the 5 is basically 62 into 1 minus r. Can make this equation 1, and sum to infinity is 64, right? So this implies that a over 1 minus r is equal to 64. Cross multiply, we see that a is 64 into 1 minus r. We can make this equation 2. Okay, do the same thing, put 1 into no, the other way around, put 2 into 1. This substitution method, guys, is key. You will see when you do calculus somewhere else, you will sometimes do this by substitution. Okay, right, so what do we see, guys? We've got a. What is a? Is 64 into 1 minus r equal to, sorry, not yet, but this is multiplied by 1 minus r to the 5, isn't it? This is going to be equal to 62 into 1 minus r. So this is a common factor. It divides out, or we can divide it out to 1. And what do we have left, folks? We've got 64 into 1 minus r. Actually, let's not do this. Let's just isolate this. It's 1 minus r to the 5. It's going to be equal to 62 over 64. Okay, so we continue, we isolate r to the 5 is going to be equal to, we transpose that, it's going to give us 1 over 32. So this implies that r to the 5 is 1 over 2 to the 5. Therefore, r must be half. And it makes sense. For a convergent geometric sequence, r must be less than 1, greater than minus 1. So as you can see, perhaps you would find this more comfortable and more easy, but whatever you do, guys, if you can do the right operations, there's nothing wrong in doing so. Okay, let's do the last question. 2.3 says, Kanya FM, a community radio in Butterworth, had a competition where the prize money is awarded over a period of 5 days. Okay, this is applications of sequences and series. On the first day, 5,000 is given to the winner. On the second day, 80% of that prize is awarded to the winner, and so on, such the prize money continued to be 80% of the amount awarded on the previous day is given to the winner of the day. Wow, a lot of things here. I don't know why they don't know how to summarize these people. Don't say too much, man. It doesn't mean anything. Anyway, folks, we know that if we see a percentage or a rate or something, this is geometric, isn't it? So this is a geometric sequence, or GP. We can call it a progression because it's a sequence of events. So where the first one is 5,000, now 80% of 5,000 is what? Let's see, 5 squared multiplied by 80%. That should be 4 grand, isn't it? Yebo, yes, Simon. So this is 4 squared there. Then 80% of 4 squared is a 3.2. 4 squared multiplied by z8 is a percentage, z everything. This is 3. This is 3 squared 32. We had 5 terms here, so we've got 3 now. So let's do the thing. So this one should be 2 squared 560, right? The last one is gonna be 80% of that. Is 2048. Okay, that's it. Because we're told there's just 5 days here, so that's essentially what happens. Right, so let's see. Is it a geometric sequence or a geometric progression? Yes, indeed. I mean, the rate is 80%. So what's 80% is 0.8, eh? 0.8 is 4 over 5, is it? Yes. It's 4 over 5. So we know that R is going to be 4 over 5, right? Of course, we can just take 80% and deal with it, isn't it? This is 80 over 100. So 20 goes, to 80, 20 goes 4 times, yeah? To 100 goes 5 times. Yebo, yes. See? Easy things, guys. You don't need to crack your skull. 2.3.1 says, how much money was given to the winner on the 4th day? We did it. So this is going to be 2,560 rands. Nice and easy. Or, for those of you, this is just for 1 mark, you can say T sub n is a r to the n minus 1. Now we can say T4 is going to be 5 squared r is 4 over 5 to the 4 minus 1. T4 would be whatever you get, 5,000 into 4 over 5 cubed. It's 2,560. So remember, this is the money. $2,560. That's another way of doing this. And of course, you're just getting 1 mark. So don't panic. Whew. Okay, so this is going to be 2.3.2. This one says how much money is given out by the station over the 5 days. That's the sum. So we know that S sub n is going to be A into 1 minus R to the n. Why the choice? Because we can see that our common ratio is a proper fraction, which means it's less than 1. So this is 1 minus R. So this means S sub 5 is going to be 5,000 into 1 minus R is 4 over 5. That would be to the exponent 5, all divided by 1 minus 4 over 5. Okay, therefore S5 is equal to, let us see. So we've got 5,000 into 1 minus into 4 over 5 to the exponent 5, close it, divided by 1 minus 4 over 5. So we get 16,808 rands. So that's it. So this is very easy. Please, the answers must have the unit of measurement. You can even write there for 16,808 rands was given over the 5 days by the competition, or whatever this is, the station. Right, substitution, guys. Answer is usually good enough. And I think knowing that the common ratio is going to be 4 over 5 is the third mark. Okay, makes sense. So 3 point, we've got 2.3.3. Now it says if Kanya FM has 22 squaddles, right, to give out for this competition, over how many days? How many days could this competition last before there is no more money to be awarded? Okay, so that's not a problem. So the sum here is supposed to be 22. So we know that Sn is nothing but A into 1 minus R to the n all over 1 minus R. Please write the formulas so that we know what you're doing. Remember the instruction. Whatever you used to determine the answers, we must see it. Okay, so this is 22,000 equal to 5,000 to 1 minus 4 over 5 to the exponent n, that's what we want, all divided by 1 minus 4 over 5. Okay, not a problem. So this implies, now what are we going to do there? We will just do some quick gymnastics and say this is 4 over 5 to the exponent n equals. So now what we're going to do, we're going to take 22 squaddles, we multiply this by 1 minus 4 over 5, right? So that gives us what it gives us, and then we divide this by 5,000. Hey, Mike, something is not making sense here. It's not making sense. So this is basically going to be 1 minus, right? It's going to be 1 minus 22,000. Okay, let's do this. It's going to be 22,000 into 1 minus 4 over 5, right? Right. And all of that divided by 5,000. Great. So what we get here is 3, oh Lord. This is 3 over 25. Now we cannot express this exponentially, so we need to introduce logs. So we know that the log of 4 over 5 to the n should be equal to the log of 3 over 25. Right? Now using log rules, we know that n is going to be the log of a number 3 over 25. Using the concept of change of base, then the base is going to be 4 over 5. So this implies that our n is, let's see, we've got now log of 3 over 25 to the base 4 over 5. What does it give us? It gives us a, this tablet is going to drive me nuts. This is 9,501791666. Okay. Now we can complete our stories on this side. So we can say therefore n must be, remember guys, this 9 tells us that we're going to be giving 80% of the amount of money as expected, but the last prize money is going to be less than 80% of the previous. So, but still that would be money, so that would be 10 days. Okay, so this competition will last for 10 full days. Then on the 10th day we run out of money, so the competition will essentially end there. So this is a nice question also. So of course guys, substitutions here using logarithmic laws and stuff, and then getting us the answer. Easy 3 marks for a full 18 marks. As you can see guys, this is very easy. This is very easy. There's no manga business over here. Alright, now let's hit functions, which is a topic of great interest in grade 12, even in grade 11, grade 10. And of course, I have given you folks a very basic video on functions so far. I'm going to start handling each individual function in as many aspects as we often look at it, just to try and get you to know and see what is going on, hoping that when you're writing your term 2 exams, term 3 and the finals, you will be as fit as ever. Anyway, so let's get to business. For this purpose of this video, we're just gonna gather some energy and get into some groove, and then after that we're gonna do wonderful stuff. Okay, we're given f of x is a third to the exponent x. Okay, right, so we can see something that when the base of our power is less than 1, greater than 0, and the coefficient of that very power as a whole is an invisible 1 or a positive 1. This says this is a graph that will appear above the horizontal asymptote, which is what? There would be a plus 0 here. This would be our horizontal asymptote. Now that's the line y is equal to 0, which is the x-axis. So essentially this means this function is going to appear above the horizontal asymptote, but if the base is less than 1, greater than 0, it is a decreasing function. So we see exactly that. So we can see this is not a transformation of what we are given. Sometimes I feel like in grade 12 we should not ask direct questions like that. I feel like we should give a particular function and give an unexpected transformation on the graph and start questioning students, because they have already done this in the previous years. Okay. Anyway, that's just my take. It should not be anything serious for those who may take this not so kindly. Anyway, the first question says, write down the domain. Now the domain, guys, is all the accepted x values. And if we look at it, the domain is going to come from the negative infinity up until 0. As you can see, this graph never touches the x-axis. So this is what represents the domain. As you can see, the graph for every x value is present, including 0. Right? So the domain here, actually I lied when I said it's excluded. It's actually not excluded. It's included. So as you can see, folks, although this is not a good graph, but you can appreciate that this graph is everywhere where x is. Can you see negative infinity? You see the graph. At 0, you still see the graph, and it continues forever. So we just write x is an element of all real numbers. Right? Some people may write x is an element of negative infinity to positive infinity. That's another way of writing that. So easy 1 mark, whichever you choose. 3.2 says we need the range of f. Okay, again, the range of f is interesting in that we can see the graph never touches the x-axis, so 0 is excluded, but after that we see the graph everywhere. Can you see? So this is what would tell us that y is y is greater than 0. Or some people may choose to write y is an element of 0, not included, and positive infinity. Again, we're getting just 1 mark for a straight answer. Can you see here? It's answers only. Do you realize if that instruction was true in the general instructions that says answers only will not, you see, that is quite dangerous to write. We should just say may not necessarily. But again, I think that necessarily part perhaps makes a bit of sense, although if you say will not, yeah, anyway, 3.3 says now write down. Again, a question that says write down. Do you see this is an instruction? This means an answer only is accepted here. So we know that the inverse of our function is such that y is equal to, now if it's an exponential, it's going to become a logarithmic function. So this is going to be the log of x to the base 1 over 3, right? Right. Or some students may write y is going to be minus the log of x to the base 3. Now folks, let me tell you, there's a few things. How did I know that this is going to be negative? How did I know that the base will have to be a reciprocal of that? Think about it, and you can tell me in the comment section if you know how I did that. But you can check it if you don't trust me. Check any x value for the equation I wrote above and the one below it. You will see that we will keep hitting the same values each time. Anyway, so this is easy, guys. We get our 2 marks. Now, that's just what happens. Now, folks, if you don't know how this is done, well, stay tuned to this channel, because I'm going to start treating the individual functions, hoping that, of course, we will have enough time for you guys to see those videos before your your term 1 exams. If not, you should already know, folks, there's lots of videos in the channel where I showed this. So just go for any full paper, for paper 1, mathematics, grade 12. You will see that when we get to exponentials, you will always have these shown, especially the older videos from 3 years ago. Those ones I show everything. But if you're not willing to check, then don't be surprised when you fail. Now we need to draw the graph of the inverse. Of course, this question I accept, because even this one I accept. These are grade 12 questions. The first two should not be asked, honestly speaking. It's ridiculous. But hey, whatever. Now we need to draw the sketch. So, I mean, we know that if the original function is decreasing, the graph will also be decreasing. So these ones are going to be symmetrical about the line y is equal to x. So I know that it should cut at 1, and it should look something like this. So I'm only going to draw it there, guys. Of course, I do have a grid at the bottom, but I mean, there's no need for me to crop it. This is the one. So I mean, I could do it. Let's pin it, then take it down. There you are. Qetile o tla re etsa letho ha ona letho o ka le etsa honna ka mona o ka se nkere selo man, hai o ka se nkere selo. Okay, we do it again, Buffett. I used to know how to make some nice don-dons, but I do have a small little shake. I think my thyroid tone is a bit high, so it gives me some issues. Okay, I think this is it, so we can just do it. There's our graph. This is the inverse function. Easy. Now we were supposed to show some other point. Now remember this point right here, it's mirror image. We just swap x and y. So somewhere, maybe this is 1, 2, we can say 3 over here. This is going to be a point 3 and -1. We just swap that. But for this kind of graph, guys, I think it's advisable to do the line y is equal to x type of graph. Here's the axis of symmetry. Whenever we draw an inverse function, we must be cognizant of the line of symmetry. And we show this with a dashed line. And of course, this is the point of intersection of these two graphs. Of course, it's not quite perfect, but yes, that's it. But sometimes the instruction will say, show any line of symmetry. If it is not perhaps indicated, you may not have to, but I would suggest just do it. Just do it. When we draw inverses, we need to consider, especially if we're drawing the original versus the inverse, there has to be the line of symmetry because they are symmetrical about this line. Okay, folks, so what do we get here? We get a mark for the shape, right? We get a mark for the point that was asked. And I would suggest that essentially, guys, the x-intercept, knowing that the y-intercept would be this x-intercept in the inverse, is good, or one can consider the inclusion of the line of symmetry, because when we are drawing these on the same set of axes, then we should consider the line of symmetry. Unless we're drawing the inverse function alone, then there's no need for the line of symmetry there. Okay, all right, okay. So let's do 3.5 over here. So 3.5 says write down, can you see, answer only, the equation of the asymptote of the inverse when we shift this graph horizontally. Can you see this is a horizontal translation to the left? Now remember, the asymptote is what in the original? It's the y-axis, which is the line x is equal to 0. But now we're going to shift it to the left 2 units. So this means the line of symmetry is going to be x is equal to -2. Nice and easy. And of course, for those who don't know what I did, I took the line x is equal to 0, which is the original asymptote for the logarithmic function. Then I moved it 2 units to the left. And that's how I did it, for those who don't know. See, very nice questions, guys. Understand notation. If you don't understand notation, you don't understand what other operations necessary, you will die. Remember, it's a plus within the function notation, but in actual fact, when we're moving an actual structure or function, I mean a point on the graph, we actually subtract from it. Okay. Now, folks, that was an easy 9 marks to score for students who were prepared here. And yeah, the questions were fairly easy to do. Okay. I normally would like to ask extra questions, but for the sake of time, let's just move on. On those individual function videos, I'll try to go to town with everything that I can think of so that you guys can become aware of a whole lot. Question 4, we are given h of x, which is the hyperbola. Right, so it's written in a way that is not exactly standard, but it's not bad either. Okay, right, so we are told to write down, write down the equations of the asymptotes. Again, this is a wrong question for grade 12. There's no need to be asking this. So 4.1, we know that x is going to be equal to 3 and y is going to be 2. So with this one, we take the one that has x, we equate it to 0 and solve for x. For the y, we just take the value that is there. Okay, nice and easy. Of course, for those who want to know what I did to know this, let me show you here. Essentially, h of x is, we will take the -2 and divide by the x term, so it's going to be x minus 3. Then we transpose the 2. So I made a mistake, guys. It cannot be 2, but we equate this bracket. When it's like this, is, you see, sometimes exploring something will save you the pain. See, we take this bracket, we equate it to 0. When it is given like this, we equate it to 0, and then we solve for y. So this should be -2. So that was a catch. See, sometimes thinking of the standard form, because this format is in the form of f of x is a over x minus p plus q. So sometimes it helps to think of the standard form before you respond. As you could see, I could easily have lost a mark carelessly. So 1 mark for each. We go on. 4.2 says calculate. Now you see, this question says calculate the x and the y intercept. Now you cannot present an answer only in a question like this. It's not acceptable. Okay, let's start. For x intercept, it is such that we've got 0 plus 2 into x minus 3 equals -2. So this implies we divide, so x minus 3 is going to be equal to -1. Therefore, x is going to be 2. You can say, therefore, the x-intercept is going to be 2 and 0. That's easy. We sorted it out. Now we go on for y-intercept. It will be y plus 2 into 0 minus 3 equals minus 2. I mean, you can choose whichever you wish to use here. So we will understand that essentially y plus 2 is going to be equal to 2 over 3. Right. And then what do we have here? Y is going to be equal to, we move this, minus 6 plus 2 is going to be minus 3 over minus 4 over 3. Oops. Okay, so therefore the y-intercept is going to be 0 and minus 4 over 3. Okay, that's easy. So when we finish a calculation, always attempt to show that you are closing the arguments there. It's not continuing. Okay, right, folks, so what are we getting? Intercepts are points, so I think showing these as ordered pairs is important. 2 marks, I think that should be fine. I don't understand 3 marks here. I really don't. Perhaps we can say for the way we did it, 1 extra mark, meaning substituting the zeros there. Maybe this business over there. I don't know. It's really stupid and crazy, if you ask me. This is why this question should not be asked, but rather ask questions that may require a student to first find the intercepts and then move on. But to just ask them directly like this is against their level of study. I mean, these are grade 12s, guys. They are not grade 11s. Anyway, clearly sketch the graph showing the asymptotes and the intercepts and wara. Right, so let's go get the grid. At least we have it here, so we have to take advantage of it. Let's do the AI things, the AI things. Let's pin it, boyki. Hey, kenapha wena man, ndibeka pha man, suyapho uthanda khona. Asuyapho kuthanda wena, nhloko yegusha. Eqinileyo, hayibo. Inenkani. Suba nenkani wena sansunqhela. Okay guys, it's giving me a headache, so let's just leave it at this position. Right. Just make it nice and sizable so that we can see it. Obviously, guys, we're going to have an asymptote at x is equal to 3. Okay. So there's our asymptote. And remember, we do it in a dashed line. Okay, so that's the asymptote that we have. The horizontal was at minus 2. Please make sure it spans the grid, okay? Don't do things that don't span the grid. Wow, we are out of power. We cannot be out of power, guys. Okay, guys, so you see this grid is so ridiculous. I hate it. Anyway, it's good. Let's do it. Let's just do it. Now, we were told the x-intercept is at 2, y-intercept is at 3 over 4, minus 4 over 3. 4 divided by 3 is what? It's 1,3. Okay. So this is 1,5. So 1,3 should be somewhere there. Okay, so there it is. Bafwethu. We will do the things. So we know that the graph comes up nicely. The graph comes up nicely, and it's gonna do this too. Okay, right. We need to just show our points, and it's done. Now we need to label it somewhere, so we can label it there. Say this is H. Was it? Yes, 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 yes. So you see guys, they're given a grid which makes it look a bit silly, but hey, the work is sorted. Again folks, what do we get? A mark for the shape, meaning where these are. I mean, we know that when A is negative, which is this value over here, the graph is going to be in the second quadrant and fourth quadrants. But because of the asymptotes shifting, this will be shifted to the right and down. Okay. Easy, 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 easy. If you like, you may even indicate here H of X. The way it's given such that y plus 2 into x minus 3 is equal to minus 2. Or you can write it in standard form. No issues over there. Okay guys, so mark for the shape, mark for any of the intercepts, be it x and y, and then a mark for the correct position of both asymptotes. Now this means for intercepts, both of them must be correct to get a full mark. And for the asymptotes, again, they should be represented correctly to get that mark. Okay. So 4.4 says, if g of x is equal to h of x plus 2, write down the equation of the vertical asymptote. Okay. Now remember, this graph is being shifted horizontally to the left by 2 units. So the vertical asymptote is definitely going to be affected. So we know that x is going to be equal to 3 minus 2 is going to be 1. And for those who don't know, I will take x equal to the first asymptote from the original. And then to move this to the left 2 units, I'm going to subtract 2. And that's how I know I'm going to do that. Okay, so this is an answer which is very easy to get. 4.5 says, if the graph of h is symmetrical about the line y equals minus x plus c, and we know that this is the axis of symmetry. Determine the value of c. That's not a problem. There's 2 ways we can write the equation. Y is equal to minus x plus c. But now we're going to take what we call the center of our hyperbola. The center is where the intercepts, the asymptotes meet. We say it is orthogonal. They meet at right angles. So that's why we call this a rectangular hyperbola. It's because the asymptotes are orthogonal to each other, meaning they are at right angles with each other. And of course, in the orientation that we expect, horizontal versus vertical. That's orthogonal. That's the technical mathematical term, which you should know, by the way. Because why we say this is a rectangular hyperbola? It's because the asymptotes meet at right angles, essentially in an orthogonal manner. Why do you say this? It's because the vertical axis is as it is and the horizontal axis is as it is. Naturally, okay, it's not swung about like in a regular hyperbola where these meet, yes, at right angles still, but the orientation is not on the vertical versus horizontal axis. I hope you understand these things. So we would say perpendicular but not orthogonal. There's a difference here. Orthogonal versus perpendicular. Yes, orthogonal constitutes a perpendicular relationship, but in the true vertical and horizontal sense. That's what we say orthogonal. But if they are just perpendicular, but in a rotated axis, so to speak, like in a regular hyperbola, then you cannot say orthogonal, but they're just perpendicular. I hope you understand the difference. Because, hey, folks, you're going to get punished if you miss these things. Now, what is this point, folks? This is 3 is 2 minus 2. So that's our center. So we will say, well, taking our center, which is 3 minus 2, remember, the axis of symmetry passed through the center of the graph. It will be such that minus 2 is equal to minus into 3. Please show these substitutions plus c. Therefore, c will be 1. Nice and easy. So this one just answers the question nicely. So substitutions and answer. So this is good. But what happens if you write the answer only? Well, that's acceptable because the question just said determine. So you can do it by inspection if you want. Now let me show you the other technique, which is quite attractive. Y is equal to minus into x minus p plus q. This implies that y is equal to minus into x minus p is x minus 3 in here, minus 2 over there. Ooh, what am I doing? What am I doing? So this implies that y is equal to, distribute, it's going to be minus x, plus 3 minus 2 is going to be plus 1. You can say therefore c is equal to 1. So that's another way of doing this. Okay, please guys know these things. To write it in this format and to give us the answer is what we want. So this is more of a generic term, or at least a method of showing that this is what we used to determine our answers, if at all someone is interested. Okay guys, so that's easy. We're taking our 11 marks with this big smile on our face. Sitting on my cry nice, amanandi. Okay, so yeah, this is easy guys. You cannot tell me that this is difficult. Anyway, let's just pause and charge the tablet and then carry on. Okay, grade 12, there's a bit of power, so let's continue so that we can finish. Right, so we're looking at question 5. So the graphs of f of x equals minus x minus 2 and g of x equals x squared minus 6x minus 16 are given. The graphs intersect at A and Q, so we can see there that they intercept and they have a common x-intercept, and they also meet there. Now A and B are the x-intercepts of G. Okay, we can already see that. Okay, easy stuff. Again, folks, these questions have been given in a way that makes it very easy to figure out what to do. First question, determine the length of AB. Of course, this is a good question for grade 11s, grade 10s, grade 12s. I mean, it's one of those you can say, okay, fine, it's an indirect question, so we can accept it. But now we know that A and B, guys, are the x-intercepts of the graph, right? Such that we understand that G of x must be equal to 0. Right, so this implies x squared minus 6x minus 16 should be equal to 0. Now we can attempt to factorize this trinomial. We've got x factors of 16 that can give us a 6. It's going to be minus 8 plus 2. Again, folks, this must be very easy. So we know this implies that x at A is going to be minus 2. And x at B should be 8, isn't it? Yeah, so we can say then AB is going to be x at B minus x at A, which implies that AB is going to be 8 minus into minus 2. Therefore, AB is 10 units. Nice and easy. Okay. This is quite a common question. It's a standard grade question, to be honest. But I think it's acceptable at all three levels, grade 10, 11, and 12. Okay, so what are we doing here? Factorization, the method, and the answer. And we can say that knowing that we have to equate this to 0, maybe it's an extra mark. It doesn't really matter at this stage. We just take the marks and go. So 5.2 says we need to determine the coordinates of Q. So already we know the coordinates of A. So we know that, folks, at Q, it is such that our f of x is equal to g of x, isn't it? Those two graphs are equal. So this implies that minus x minus 2 is equal to x squared minus 6x minus 16. Now this is quadratic. We write it in standard form. X squared minus, it's going to be minus 5x minus 14 equal to 0. Then we attempt to factorize. Again, this is not a difficult question. Factors of 14 that can give us 7, when we add them up, it's going to be minus 7 and 2. Again, so we can easily say that x at Q is going to be 7. I'm ignoring the minus 2 because we know that it is x at A. You can say therefore y at Q is going to be equal to we can take the easy equation minus into 7 minus 2, which is going to be equal to minus 9. You can say therefore point Q is 7 and minus 9. Okay, very nice and easy. So obviously equating the two equations was important, factorizing, finding the x coordinate and the y coordinate. Of course, we need to present this as an ordered pair to earn our last mark. If not, we lose that mark, okay? Take this for granted at your parish, okay? Right, so 5.3. We now need to show, once we are told to show, it means we can't just come up with an answer only. Show that the coordinates of the turning points are like that. Of course, we know that g of x is x squared minus 6x minus 16. I can simply just complete the square to make it easier for myself. So we know that this is going to be x minus half of 6 is going to be 3. We then square this. Minus 16 minus 3 squared immediately. Can say therefore g of x is, this is x minus 3 all squared. Now this is going to be minus 16 minus 9. This is going to be minus 25. Can say therefore the turning point is going to be 3 and minus 25. Nice and easy. So basically we just change the sign of what is inside the bracket and we take this as it is. Now folks, writing this in the vertex form is a mark, and then getting those two coordinates. Although they were given, we still get our marks. In fact, it looks like we're getting just 2 marks. Okay, we can say fine, 1 mark for the whole thing. And of course, there's nothing wrong with those who prefer to write x is minus b over 2a is 2y, which is going to be b squared minus 4ac. Sorry, it's the other way around. It's going to be 4ac minus b squared all over 4a. So that gives us the coordinates of the turning point, or any other way you guys know of. But one thing for sure, you're going to get the same answer. 5.4 says, for which values of x is f of x greater than g of x? So when do we see the graph of f above the graph of g? So we see this over here, folks. You can see that over this region, all these x values give us y values such that those of g are less than those of a. So that's what we have. So essentially, we know that x must be less than the 7, which is that at q, greater than -2, which is that at a. We cannot include those because the inequality says greater than. The other way of thinking about it is to say the graph of f must be above the graph of g. And we see this in this section, because we can see there's the graph of f. It is certainly above the graph of g. So that's how we read that. So easy, 2 marks, nothing complicated. So 5.5 says, determine for which values of k will this issue equal to 0 have 2 equal roots. Okay. So now, folks, we need to start comparing and contrasting, because we will see that we've got x squared, we've got x squared, we've got -6x, we've got -6x. Now we have here, what we have here is something else. Now we've got -16. Instead here we've got this issue. Okay, we can leave k, but we look at the number. How did we end up with a 4? And of course, there's this k. So this is already telling us that this is our parabola g, but already transformed. This is already transformed. But now the intention is to transform it further, right? So we need to transform it further, because k is going to be a vertical transformation, isn't it? Or a vertical translation, to be honest, or to be exact, sorry. But now how did we get 4 from -16? So we say -16 plus what? Since this is going to be a y value, is going to be equal to 4. So we know that if we transpose, we know that y is going to be 4 plus 16, that's 20. So this means we must have added 20, meaning we shifted this graph upwards by 20 units to end up at +4. But then we are shifting this further. Now let me demonstrate what this looks like on the actual graph. So let's say this is our parabola. I'm just going to try and outline it. Right, so we take it up. So we know that this graph is shifted up by 4 units, sorry, by 20 units. So now let's see. This goes up to +4. So if we're going to say +4, that means we're going to take our y-intercept up a bit, okay? So this is going to go to somewhere, say either here, but this should be above this point. So it can be right there, can be slightly above, we don't know. We leave the graph over there. But now, if we move this graph 20 units, mind you, the minimum value is -25. So if we say -25 plus 20, this is going to be -5. So this means our turning point still on the negative. So this would be somewhere around there. Okay, we can accept that. But now we want to further transform this graph a little bit more so that we end up on the x-axis. So guys, these kinds of questions unfortunately are going to be quite challenging. So this is what is the ultimate. So this is what we want eventually, so that we've got equal roots over here where they are exactly equal, because there's a repeating root. So obviously if we're sitting at -5 over there, folks, this means we need to shift this 5 units up, and 5 units up is positive, so we can say k must be equal to 5. Nice and easy. So we did this by the graphical method, but remember, there is no explaining what happened if you don't know the actions that are needed. So this is very important. So the graphical approach sometimes can be technical if you're not comfortable. But we always have something up our sleeve. We can use our nature of roots. So we can say, well, for equal roots, we know that b squared minus 4ac must be equal to 0. And then b is the coefficient of x, which is -6 squared minus 4 into 1 into k plus 4, right? Must be equal to 0. And then this is 36 minus 4k minus 16 equal to 0. We transpose 4k equals 36 minus 16 is 20. Right, so k is going to be 5. Of course, there's no need to show the calculation because it's just 2 marks. You may just do this as a rough work, essentially, and then just present the answer only. Okay guys, so I don't know when this stopped, because it seemingly has stopped. You know, sometimes some actions, you touch things and then things happen. I don't know what you missed, what you did not miss. Hey, this one is quite scary now. But anyway, we'll see guys. I will just try and watch the video and see if everything is captured. If not, hayi bafethu nansi imemo yakhona nani nizozibonela ukuthi wenzakale. As you can see, we are just shifting that parabola somewhat. So now I noticed the video is not moving, so I don't know when it stopped, and I don't know what you guys are missing as a result. Let's just carry on. Alright, otherwise guys, I'm gonna have this memo in the description so that you can have a look at it for yourself. See if you can learn anything when you're sitting on your own. Now let's get to trigonometry. Again, this is just another form of algebra. Now we are told sine 56 is q, so 6.1, we are told sine of angle 56 is equal to q. Okay, now we know folks that the best way to do this is to write it as a ratio, because this is q over 1, and we already know that the terminal arm is in the first quadrant because 56 is an acute angle, so we need to do that. And of course this is the x-axis, the y-axis, the origin. 56 is an acute angle. What should this one be? 34. Let's see. Yeah, it should be 90 minus 56. Yep. So do everything, don't wait to be told. So this is q. And of course the hypotenuse is going to be 1. For us to solve for x, x squared plus y squared equals r squared. This is from Pythagoras. Don't take anything for granted. This is plus q all squared equals 1 all squared. Therefore, x, it's on the positive side, so it's going to be the positive square root of 1 minus p squared. Now, folks, this is important to not wait to be asked this. Usually, when this instruction is given, the diagram is our absolution because we get stuck along the way if we don't do that. So let's answer the question 6.1.1. We need to find the value of sine of minus 56 degrees. So this is equal to sine of a negative angle is minus sine of the angle. So this is going to be minus q. Easy. So obviously the reduction in the answer, that's 2 marks. I don't know why this is 3 marks. It should be 2. There's no justification for giving more. Alright, so 6.1.2, we need to evaluate tan of 124 degrees. This is essentially a big angle, so this is the tan of 180 degrees minus 56 degrees, isn't it? So tan in the second quadrant is negative, and we reduce it nicely. So tan is adjacent, opposite over adjacent, so it's going to be minus p over the square root of 1 minus p squared. Now in grade 12, we don't need to rationalize the denominator, but if you are in grade 11, you are not allowed to not rationalize. You have to rationalize. Right, folks, so this is good. This is good. And the mark for the x value because it wasn't given. So that's how we score the 3 marks for that question. So 6.1.3. We now need to evaluate cos of 4 degrees. Now this is a true grade 12 question. So how did we get 4? So we know that cos of 4 degrees is the same as cos of 60 degrees minus 56 degrees. Now remember, this could even use that 34 if at all we had to. But a combination of special angles is going to be good. So this is equal to, what is this? It's a compound angle. So cos of the first angle times cos of the second angle. The sign changes. Sine of the first angle times sine of the second angle. So this is equal to cos of 60 using our special angles, it's actually a half, into cos of 56, it's just going to be root of 1 minus p squared, plus sine of 60, this is root 3 over 2, into sine 56, we were told it's q. Now we simplify, okay? We can't leave the expression unsimplified. So this is just going to be the root of 1 minus p squared over 2 plus a root 3 q divided by 2. Now common denominator is 2. So we must simplify until we can't. So this is just going to be 1 minus p squared plus root 3q. That's it. Okay, guys, we cannot simplify further than this. So that is it. Okay. Now we move on. Of course, guys, if you choose any value for p and q, remember these are constants. They are not variables. These are constants. If you choose a value for p and q, then you evaluate the answer here and you go on directly and say cos of 4 degrees. You will see that the answer will be the same to prove that this reduction or whatever this simplification is correct. So I would suggest that folks do check all of these things. The same can be applied here. If you just choose any value for p, because these are constants. And then we just see what we get over here, and we just punch that directly. So I will say, folks, please check. Check, 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 check. So that you don't leave these things unattended, or at least you don't get wrong answers. Here you can truly check. You can truly check, okay? So even with the first one, but the first one I think it's too simple. There's no need to be convinced of anything. So yeah, it's as simple as that. So how many marks are we scoring here? Well, I do think this writing is key. Expansion, part of the three-step approach, using special angles and the diagram, and the final answer. So that is indeed a 4-mark question. So we are sorted. So let's move on. 6.2 says, use the identity of cos A minus B equal to cos A cos B. Can you see we just used this identity above? Now to prove this identity, again, proofs, guys, I have shown you. There's a video that I showed you where these identities came about. The compound angle identities as well as the double angle identities. You need to know those proofs. Right, so our task is to deal with sine of angle A minus angle B. Right. So what is this equal to? This is equal to, now we need this to look like cos, so we're going to use cofunctions. So this is cos of 90 degrees minus the difference of those two. Right? So it's as simple as that. So cos of, now we just regroup these things, it's going to be 90 degrees minus A, then minus into minus B, because this would have been a plus, isn't it? So we just want the negative. So the key thing is to have a negative between the two angles. And we now have exactly something similar to what we had. So it's going to be cos of the first angle, 90 degrees minus A, times cos of the second angle, which is minus B. The sign changes to sine of the first angle, okay, there it is. We go on. Cofunctions kick in, though this is going to be sine A, cos B. Cos of a negative angle is positive, plus this one changes to cos A times minus sine B. Okay, then sort it out. So it's going to be sine A cos B minus cos A sine B. So of course we can just continue here. Alright, so this is the story. So we are done here. That is an identity for sine. Compound angle, whatever. Right, so folks, this situation is usually good to use cofunctions, but I feel like there's so many marks to consider here. Even this expansion would be enough to give a mark, and the use of cofunctions, so this should be 4 marks, to be honest. I don't know why we are being given less, but maybe 3 at best, because obviously the answer was volunteered somewhat. So I would suggest this should be the case, but because this is a logical thing, even the mark could be given for the final answer, although it was given. But I think at this stage we can leave it there and say at least 3 marks, guys. not less than that. But this is where you just realize the examiners will always do their own thing. Right, let's get to the next question. It says simplify to a single trigonometric ratio of a. Okay, so we've got sine 2a cos of minus a plus cos of 180 degrees plus 2a times sine a, all divided by sine of a minus 90 degrees. Now we need to figure out what is going on. So it always helps to inspect. So I've got sine a is going to be cos a. Now cos can change to minus cos 2a sine a. So this looks like a compound angle for sine in expansion. So we can just simplify this and say this is sine 2a. We keep this. Cos of a negative angle, it's going to be positive. And then, because this is going to be negative cos 2a times sine a. This is all divided by, now this is an angle in the fourth quadrant. Sine is negative, so this is going to be minus cos a using cofunctions. Right, now for those who don't know what happened here, there are many techniques here. You can just say sine of a minus 90 degrees, the same as sine of, we factor out a negative, we get 90 degrees minus a. Now sine of a negative angle is negative, so this is minus sine of 90 degrees minus a, and then this is going to be minus cos a. Okay, so that's the story over there. Or another one may just look at the Cartesian plane and say, look, if I write the sine of a minus 90 degrees, it is the same as sine of minus 90 degrees plus a. So minus 90 is essentially 270. Now if I'm saying plus a, this is a positive, so I'm moving into the fourth quadrant. So when I use 270, I use cofunctions. So angle A is that angle. So you can see that's exactly going to say sine must be negative there. And so its coratio will be negative. All right, folks. Other people are told to add 360 whenever they see angles greater than 360. Sometimes here you may decide to add 180 if you will. That would not be a problem. But if you do that, it would give you an incorrect answer. So maybe to add 360 would be good because it reveals this 270 essentially. So if you say plus 360 here, you will get 270 degrees plus a, which already tells us what I just showed you. So there's a lot of ways to get things done here. So as long as you are strong in your maths, your algebra and arithmetic must be 100% solid to survive here. All right, so now we can see this is a sine compound angle identity in expansion. So now we contract it. So this is going to be sine of the first angle minus the second angle divided by minus cos a. Now 2a minus a is just going to be sine a divided by minus cos a. Now cos over sine for the same angle is going to be minus the tangent of a. Now this is in its simplest form. Again, you can check here by choosing a value for a and see minus 10a what it gives you. And you go into the expression, you substitute the value that you chose for a, you put it on the calculator and see if you get the same answer. Please don't leave these questions without checking. Because guys, you lose marks over silly mistakes that you will have committed in your business right here. But if you check, you are going to see that mistake and correct it. There's no way this thing checks out and yet it's wrong, okay? it's not going to do that unless you copied the expression incorrectly. Then the check will be correct based on what you did, but wrong for the actual question. So make sure that you copy the correct thing. Anyway, when we use our reduction formula here, we get a mark. All reductions, guys, we get marks. So can you see, by just the first step, you get all your marks. If you get stuck along the way, that's it. Out of 5, you have 3. You've passed that question. And then, of course, when we use identities to contract, that's another mark. To know that sine over cos is a tangent. So that's it. That's how we score our 5 marks for that question. Okay, so let's look at 6.4. 6.4 says, we're given this identity and we need to prove it, okay? So we're going to say 6.4.1. The left-hand side looks nice to start with, so we know that the left-hand side is equal to, we write it as it appears, cos 2x plus cos squared x plus 3 sine squared x, all divided by 2 minus 2 sine squared x. Now take a pause and have a look at the expression. We've got cos, this is sine squared x, and then there's a sine in the denominator. So how about we change everything into cos if we want, because we can see our answer has a cos in it. So we can change everything into cos, and just get on with it, because we know that we want cos. So this is possible. So this is going to be, that cos 2x is nothing but 2 cos squared minus 1, then plus cos squared x, and then plus 3 sine squared x is 1 minus cos squared x using our identities. This is divided by 2 minus 2 into 1 minus cos squared x using our square identity. Now we just sort out this thing. So 2 cos squared x plus cos squared x is going to be 3 cos squared x minus 1. Then we FOIL here is going to be plus 3 minus 3 cos squared x, all divided by, and I have 2 minus 2 plus 2 cos squared x. Okay, that's easy. Now we can see that these are like terms, so they will cancel each other to 0. So minus 1 plus 3 is 2, divided by 2 minus 2 again is 0. So what we have left is just 2 cos squared x. Now 2 divides 2 into 1. So this remains as 1 over cos squared x. This is equal to the right hand side. So the identity has been proven. So this one is easy. It's already proving itself. So when we use identities, we get a mark. Identities, we get a mark. But we're not going to get 2 marks for the square identity twice, I suppose. And then, what is that? We can say, well, for the troubles, 4 marks. How many marks? 5. You see, again, this is crazy. So this means this one is a mark. Anyway, whatever. That's it, guys. We've got it. Easy 5 marks. This should be 4, actually. Alright, so let's look at 6.4.2. 6.4.2 says we need to determine the value or values of x in this interval where this identity will be undefined. Now remember, guys, I said undefined doesn't mean non-real. There's a difference here. Undefined just means we cannot evaluate because there's too many solutions. Or you can just say this is as good as saying element of real numbers. Okay, it's just as soon as that, meaning the identity itself is an element of real numbers. It can be any value. That's what undefined means. But when we say non-real, it means it does not exist. Okay. Or it's imaginary if you think about it, or it's complex. Now we know that, okay, this happens when we factor in the denominators. Either that denominator or that denominator has to be 0. So let's take the first one. We know that this is going to happen when 2 minus 2 sine squared x is equal to 0. We transpose everything, we get 2 sine squared x is equal to 2. So this implies that sine squared x is equal to 1. Okay, let's move on. So this implies that sine x is going to be plus or minus 1, right? Because we're going to take the square root on either side. This is easy, guys. That's what we're going to do. So now, what is this? So this is already telling us that essentially x must be equal to, when sine is 1, this is 90 degrees. Is there any other? No. Because when it's minus 1, this is when it is 270. So we don't have this in the first quadrant or first two quadrants. So it's only at the border when it's 180, but sine of 180 is 0. Now if this is 0, this would mean we have 2, but now the whole thing has to be 0. So the only answer here is 90 degrees. Nice and easy. Okay, folks, knowing that this should be equal to 0 and getting the answer is what we want. Okay, good. Or for those who are brave, we can actually take cos squared x and say this must be equal to 0. So this implies that essentially cos x is going to be equal to 0 when we take the square root on either side. 0, you can't say plus minus. So you can say therefore x is going to be the arc cos of 0, which is 90 degrees. Okay, so that's an option. So these are very easy questions to really solve, guys, because it's all about knowing. I need to equate the denominator to 0 and get an answer that would satisfy such a condition. So this is a very simple question, nothing really out of the ordinary. Let's look at 6.6. 6.6 says determine the value of. Now this looks familiar. I have done this on one of my revision videos, I think. But if I want to think even a bit far back, I'm not too sure whether it was the May-June exams last year, but this was after the Term 1 exams. But those who actually reviewed these papers and who were doing the May-June exams, can you see, you're not going to ignore the DBE papers, or should we say the NSC papers, just because you're going to be writing the senior certificate in May-June. But of course, it's both senior and NSC, depending on who you are and how old you are. So this question is very easy, guys, if you plan, but you don't rush. You don't rush. You start by looking. I've got 10, 1, 2, everything is increasing by 1 in terms of the angles up until 89. And 89 is an odd number, okay? So I know there that I have 10, 1 degree times 10, 2 degrees times 10, 3 degrees times 10, 4 degrees times dash 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 times 10, 87 degrees Oops, okay, let me just answer the call. Okay guys, so done. So 87 times 10, 88 times the tangent of 89. Okay, so this is cool. So what does this mean? This is the same as the tangent of 1 degree. Maybe let's do it this way. We know that the tangent is just sine 1 degree over cos 1 degree times sine 2 degree over cos 2 degrees. Sometimes you don't know where you're going. So this is tan 3 degrees over cos 3 degrees times sine 4 degrees over cos 4 degrees. Okay. Now this is multiplied by dash dash dash, but now we can see there's just 3 terms. Now let's put 4 like it was at the beginning. And say the 4th term, of course, would be 1 before that. So this would be essentially sine of, this would be 86. 86 is nothing but sine of 180 degrees minus 4 degrees. All divided by cos, of 180 degrees minus 4 degrees. You see, now there's something that's coming up. Multiplied by sine, did I say 180? No, man, it's 90. It's 90 degrees minus 4. As you can see, we're getting some things that we had at the beginning. So this is going to be sine of 90 degrees minus 2. Okay, what am I doing now? This is 86. 86 is 90 minus 4. 87 is 90 minus 3, okay. All divided by cos of 90 degrees minus 3 degrees multiplied by, this is going to be sine 89 is 90 degrees minus 1 degree divided by cos of 90 degrees minus 1 degree. Now we can already see what's happening here. When we reduce, so this one says sine 1 degree over cos 1 degree multiplied by sine 2 degrees divided by cos 2 degrees times tan 3 degrees divided, yes, you see. How did I end up with this? My Lord. So this was meant to be sine. Can you see mistakes happen, guys? You'll be surprised how often very silly mistakes and costly mistakes actually occur so frequently despite your concentration. Cos 4 degrees. Actually, I'm distracted by the phone call. Excuse me, that I just had. Okay. So there we are. So this is multiplied by dash dash multiplied. Now we use cofunctions here. Sine minus is going to be just cos 4 degrees over sine 4 degrees. Times, this reduces to just cos 3 degrees over sine 3 degrees times why do I have 3 terms when I intended to do yeah man, there's something missing here. Yes, I can tell something is not right. So this must have been the other one. Sure, because You see now, and this thing is so overwhelming, this is 90 degrees minus 2 degrees over cos of 90 degrees minus 2 degrees. Okay, I wanted to write 4 terms at the end like it was the case here. So this is going to be cos 2 degrees over sine 2 degrees times by cos 1 degree divided by sine 1 degree. Now folks, we will notice something that, hey, when we do multiplication, this is as good as multiplying by the reciprocal. So these terms essentially telescope like that. You see, this chows that, while that chows that. So the telescope effect takes place here. This guy takes that guy. Same story. This does that, that takes that. But now, does everything go away completely? This is a very good question. Now we had an odd number at the end. Now with odd numbers, we want to know what would happen here. Is there a middle term or is there no term in the middle? So if we say 1 up to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, for example, you will see that 5 is in the middle. Now there's 4 on each side and 5 is the middle term. So this means here there has to be a middle term. But what angle is it going to be? We're going to use the angle, so we can just say, well, n is going to be not n, but the middle. What do you call this? The median. The median, this is going to be equal to n plus 1 over 2. So n is 89, the big number, plus 1, the first one, divided by 2. So this is 90 divided by 2, which is 45. So this means in the middle, we're going to have 10, 45. So this one we don't need to change. So this is just going to be 1 times 1 times 1 times 1, okay? Times, okay, this is going to be somewhere there in the middle, times 10, 45 degrees times, times, and again 1 times 1 times 1 times 1. Now this is as good as just 10, 45 degrees, which is equal to 1 from special angles. Okay, so this question is one of those questions that you can see you're writing a lot. You have to concentrate. Mistakes easily creep in. So watch out and make sure everything is done correctly. This is otherwise a good question for grade 12. It's certainly a higher grade question. So how do we do this, guys? For changing everything to sine and cos using the identity there, and essentially using cofunctions this side, that would be the second mark, and then the telescoping effect, knowing that there's going to be some 1045 here, I suppose. How many marks? 4, yeah, and then we get 1. I think that would be it. Okay, as you can see, some statistics techniques needs to come in. And you've done statistics in grade 11, doing the median, the mode, and all those things, even in grade 10 for that matter. So you cannot say, we haven't done statistics in grade 12. There's nothing new except the least squares regression line. The rest is the grade 11, grade 10 issue. Okay guys, so that's very easy. We're taking these nice and easy 30 marks. As you can see, these ones were just a gift from the gods, except for that 6.6. Yeah, many students would fail to do this because they're so used to doing easy things throughout. Unfortunately, it's not always going to be easy. Okay, let's wrap this up. Question 7. Question 7 says, in the diagram below, ABC is an isosceles triangle with AB equal to BC, and we can already see the units are doing the things, okay? If that's the case, it means if that angle is alpha, that angle should also be alpha, right? Opposite angles equal sides of a triangle. The next one is saying also BD is equal to AD. So this already is showing us that, well, we will have an isosceles triangle here also. And if that's the case, if this is alpha, that should be alpha as well. Because again, opposite angles. Is it what? Angles opposite equal sides in a triangle. Yeah. Alright, so that's just a quick analysis of what we have here. Now we're told to show that ADB is 180 minus 2x. So this is the angle in question. So is it so? Let's find out. Now it's clear that we're going to have to work in this triangle. But now we need to justify everything until we get there. Alright, okay. Now we can say, okay, 7.1 with 7.1.1. We can say in triangle ABD. This is the government for our answering. What do we know? We know that essentially angle A is going to be equal to angle C equal to angle alpha. Now what is this? These are the angles opposite equal sides in triangle ABC. We are using triangle ABC as a means to an end. We can say also we understand that angle ABD is going to be equal to angle A, which is going to be equal to angle alpha. Again, these are angles opposite equal sides in triangle ABD. Okay, that's where we are right now because we see isosceles triangles. Sometimes I have a tendency to state which sides are equal, but we can leave that for later. We can say here then we understand that ABD plus ADB plus angle A should be 180 degrees. So this is the sum of three angles of a triangle. Now we're talking about triangle ABD because that's the main triangle. So this implies that alpha plus alpha, no, ADB is what we want, plus ADB plus alpha is 180 degrees. Therefore, angle ADB is going to be 180 degrees minus 2 alpha, sorry. So used to x. Right, so we have shown it, guys. As show, we need to bring out everything. This statement and that statement are quite key. And of course, the substitutions, I suppose, the rest goes nicely into the end. Usually this reason, as important as it is in our calculations, it normally never gets marks. So this is from grade 8, grade 9 or so. All right, now let's do 7.1.2. It says calculate the value of cos 2 alpha. Okay, now which triangle do we know a lot about? It's still the same triangle over here because we've got this side, we've got this side, and we've got this side. Now we have the angle. So the cosine rule kicks in here. So in triangle ABD, what do we know? We know that, guys, AB squared is going to be equal to AD squared plus BD squared minus 2 times AD times BD times the cos of this angle ADB. That's the cosine rule. So we substitute. AB is 6 squared equals AD is 4 squared. I don't know, my hand is just Tired. I'm getting tired easily these days. AD is 4. Cos of this angle, 180 degrees minus 2 alpha. Okay, we move on. So this is 36 equals 16 plus 16. In fact, we can just say this is 32 straight up. Minus, this is 4 by 2 is 8 by 4, that's 32. Now the reduction here is going to be just cos of 2 alpha, but then the sign will change to plus. But this would have been minus cos 2 alpha. So we sort it out. And then we isolate cos 2 alpha. So this implies that cos 2 alpha is going to be 36 minus 32 over 32. Therefore, cos 2 alpha is the answer. So 36 minus 32 is 4 over 32. So 4 over 32 is 1 over 8. Nice and easy. Okay, it's done, guys. It's done. So writing the cosine rule in terms of the triangle in question, substitutions, this reduction, and the final answer should be 4 marks, not 3 marks. Remember, guys, when you use reduction formula, we get marks. When we, write a rule according to a specific structure, we get a mark. So again, you will see that marks are not allocated fairly in these questions. So this means some random person is setting these papers, and this is not good. Can't have random people setting exams for students. We need to have experts only, guys. Novice individuals need to be, taken under the wing of the qualified and expert people. Because qualifying doesn't mean you know what you're doing. It means you have a potential to know, but you need further training and guidance. So if at all there's any young individual who's going to be given a chance to examine, that should be passed through seniors in the game to have a look and evaluate those and challenge the examiner as well, so that everything is perfect, guys. We can't have these crazy things happening. As you can see, I am not happy with this trigonometry here, missing trig functions. Where is a question on trig functions here? I've seen a lot of unnecessary marks given to questions where they're not supposed to, and certain questions deserving more being given less. Technically, trig functions should be here. At least if it's just one graph, it's good, or two. You're either given a graph you interpret, or you're given a chance to draw a graph, or both, and respond to some few questions. This should be here, guys. It cannot be elsewhere, because the syllabus, folks, must be finished by mid-year. You see, if this was completely done, in term 2, there would just be an introduction of statistics, analytical geometry, and Euclidean geometry. And remember, Euclidean geometry for grade 12 is just 2 things: the proportionality theorem and its counterpart, which is similarity. The rest is grade 11 work. We cannot say we're teaching that. 2, analytical geometry, most of it has been done. The new thing is the circle in analytical geometry. Can you see it's just one topic? And then statistics, again, it's just one topic, the least squares regression line. That's all, because the rest has been done previously already. The histograms, the frequency polygons, the, all of those things. Let me not get to the ogive, I wanted to say the cumulative frequency graph. That's the word I was choking on. So can you see, guys, the syllabus has no excuse not being done in term 2, because for paper 2 it's just 3 topics. in fact, just 3 sections of those topics. One is just similarity and proportionality, which is just nothing, obviously, guys. This you can teach in 2 days and it's done. There's no need to teach it the entire week. And then you teach the circle analytical geometry. That's just 1 day. You don't need more than that. And then you can teach the least squares regression line. Again, that takes just 1 day. So in 1 week you would have finished those topics for paper 2. In the next week you go to paper 1. What's new? Differential calculus. Okay, that needs a bit of work, so you need the whole week to get students into the groove, because first they need to understand the limit and understand laws or rules of differentiation. And please, guys, stop teaching only the power rule and the first principles. No. Teach all laws of differentiation and examine them, okay? Because we see this in the applications, which is optimization. And this is sometimes unfair, because where do the students know this when they are not taught? I mean, if you're already teaching differential calculus, teach everything. Okay, that can need a week spilling over into the second week, because if we want to teach this right, then we need to give it time. Then that includes the cubic graph and optimization, of course. Maybe let's say 2 weeks. And then we can teach probability. Again, probability for grade 12 is just a fundamental counting principle. So there's nothing a lot to teach there. So you can do it, say, in just 3 days, because that topic is quite technical. So you need a bit of time to explain certain things and to showcase certain things. Maybe 3 days for that, that's enough. I mean, look, we're talking about 2 weeks now. Mind you, 1 week you could do all these other topics for paper 2. Then in the second week, you can take maybe, or did I say second week? No, third week. Because the 1 week would be for differential calculus, including the cubic graph and optimization. Okay, maybe you need a whole week for that. And then by the third week, you just take 3 days. You teach probability. This is for paper 1. And then financial maths would go over into perhaps the 4th week. So this is just 1 month if you look at it. Over the 4th week, when we're going to be teaching, what did I say? Financial maths. Again, to teach financial maths for grade 12, it's nothing but the annuities, isn't it? The rest is grade 11. It's just the annuities, future value, present value. That's it. That you just teach in 1 week. That's it. Guys, in 1 month, all the topics for term 2 could be done. So this means you will be able to examine students in all topics in June. Okay. Yes, maybe constituting mostly standard grade questions for the new topics, and essentially higher grade for the repeated ones from grade 11, 10 and below. And essentially, guys, come the trials, we just hit you hard with higher grade question papers. I suppose the trial paper should just contain only higher grade questions, so that you just realize if you know or you don't. So that you can study well for the finals. And I can assure you the finals should actually, be very easy to do. And you just smile. Anyway, guys, this is the revision that I could give you. And the reason I like the papers from the EC, you can see, guys, they give you an opportunity to kind of do a very comprehensive revision, but in a very nice and simple and, of course, affordable way, or at least a cost-effective way, because this one doesn't tax you too much so that you can give up on maths. It makes you believe you can do it. At the same time, it also primes you to, or prompts you to know things that are somewhat a little bit not so close or not directly linked, but you can see that indirectly they actually come into the party. And then, of course, from here, guys, you can then challenge yourselves with those hard questions for each of the sections to see if you're good enough. Okay, of course, that's going to be a bloodbath at first. Don't give up, okay? It starts off with a bloodbath for everyone. As I told you guys, my first case study from the District 5 in the East Rand. I was in Guatem at Nkumbulo Comprehensive School. So that's where I did my high school, in the East Rand. So my first District 5 Euclidean geometry worksheet that we had to do. Guys, I got 0. 0 standard cogs. And not because I didn't know, but I wasn't used to the higher grade questions. Remember, I jumped to higher grade in my grade 12. I was never taught in higher grade for grade 10, grade 11. It's always been standard grade. And I was cruising nicely thinking I know maths. Oh, came a worksheet on what I mastered Euclidean geometry for standard grade. Man, that thing. I think I answered, okay, I lied when I said I got 0, but I think I only answered one question and the rest I got stuck. I think there were about 4 questions. Hectic stuff, eh? The way I was so traumatized, guys. And my teacher looked at me. I mean, he used to see me flowing, but he could see the concern in my face. And he too, when he was walking around, he saw that I was not making any progress. And he was like, yeah, this one probably bit more than he can chew. So at the end of the class, well, I submitted a relatively blank script. And then he said, hey, boy, I think you should stop this higher grade thing. Take standard grade maths. You're going to pass well. Otherwise, this thing is going to ruin your report. You're going to fail this thing. I said to him, you know what, sir? The guy has big ambitions. And I believe in my abilities. It's just that, sir, it's lack of exposure. Give me another week. And let's see in the next case study what happens. If I still struggle, I will accept. But if I don't, I think I want to die in the field. Even when I don't make it, even in the next one, I think it's going to be hard for me to accept, but I may consider what you're saying. I'm like, okay, let's see. You know, on my way home, I used to walk from Nkumbulo, which is in Guatem Extension 4, which is almost in Springs. I mean, it's just, you can just walk maybe about 15 minutes to get to New Era train station, which is essentially being in Springs. So I would walk there all the way through Rest in Peace. Rest in Peace is a township which is closest to the cemetery, that's where it got the name Peace. They call it a Peace. I used to cut through a Peace, including Kabinde. And of course, Tibani nabafana nabantwana base Kenneth. Isikole ezazintswempu lezo according to what we believe. But yeah, anyway, we destroyed those people in the finals. That year we took #1 spot in that District 5. We nailed all of them. We were fierce, Baba. Sasquatil. I even added the cherry on top by just shooting distinctions for these subjects that were feared the most. Anyway, guys, that's just a proud moment, I guess, but of course not a breaking point. Anyway, so I used to walk for like an hour home, you know. Now, on my way home from the trauma of those questions that I couldn't answer, you know, I have this photographic memory because when I remember things, I remember details because I never look at things carelessly. So now the whole detail of those questions and the very questions, because I kept reading them, kept trying to figure out what to do. So it just came to my mind like that. So I figured, what if I derive simultaneous equations, essentially, or just derive 2 equations where there's a common thing, and then solve simultaneously? Would I not be able to solve this? And I tried it, and then it seemed like it's going to work. But of course, it was a bit of a vague, sort of rough calculation in my head. When I got home, I redrew those diagrams and of course wrote down those questions. I remembered everything. And when I did my simultaneous equation technique, voila, I could answer all of them effortlessly all of a sudden. I was like, this thing is never gonna kick me, because I was so used to direct questions in Euclidean geometry. Now when the indirect ones came, I got stuck. Now from there I realized, look, maths, guys, is comprehensive. You use everything. Now I started to see certain questions that I'll probably not be able to answer at first, but then I could now, because I knew I can just use trigonometry when I need to. I can use analytical geometry if I need to. Anything, honestly speaking. I started to see that, okay, those difficult questions actually unlocked my potential. So what I'm trying to say to you guys is, you are going to fail sometimes when you're taking up a higher challenge. But remember, that fail is not failing the class. It just lets you know you are not aware of certain things that are within your capabilities after all. But once that awareness is awakened by a serious rain check, is it rain check? No. A serious reckoning, so to speak, you start to fly unstoppably. Because after that, my teacher realized, hey man, this boy is a beast. He's doing this thing. I remember my brother, when he came from a meeting, an SGB meeting, he said to me, my maths teacher said to him, you know that boy, if we continue to work at the way that we are getting this distinction. And mind you, that was the first time my school ever got a distinction in maths. So yeah, guys, they were very good things, but they came at a serious sacrifice, dedication, the desire to not give up. Not necessarily the desire to not give up, but the desire to want something and the spirit to never give up, no matter what happens at first, because always something that is worth pursuing, guys, is always going to be challenging at first. It's not as welcoming as you wish. It doesn't care about your feelings. It only cares about itself, because you have to be the real deal to handle those challenges. And you don't become the real deal if you're lazy. And if you're complacent, you go with the wind, whatever others are doing, you want to do the same way. No. It also takes a bit of confidence in yourself, knowing that you can just do things differently than others and be okay with it. Even if they reject you or subject you to some form of scrutiny that is uncomfortable, you just take it. Because this is where you also learn to be honest with yourself, right? Because you will know now that, look, it's not about proving a point to anybody. It's about awakening myself to my cause. And if I can get it right, then you become an inspiration to others, because they know how you started. And they saw exactly the fire in you never stopped burning. Even when it seemingly was fading, you reinforced it, because certain things just simply need reinforcements. Something is already there. The spark is there. But you just need to reinforce it so that it becomes even brighter. Then the morning star, mphatlalatsane. Ke naledi ya mesontwena, re bona ka yona he hore bosiu busile. But you will never see mphatlalatsane if you didn't see the night, isn't it? You have to see the night first. So that's just the thing, guys. You guys give up when the going gets hard. And in fact, that's when the transformation takes place. If you can just persist a little longer, but not just persistence, you persevere, you do your part, you don't sit back and wait. You will see yourself starting to move away from the danger zone into the more favorable field of multiple possibilities in life. Anyway, guys, I can talk until Jesus comes back. It never ends, right? As much as one can give you practical lessons about, real stuff, you still don't learn, because you guys are just a very fascinating generation who never pays attention, who goes with the wind no matter what the cost. You try to be relevant when there's no need. In fact, when you In fact, when the situation demands that you be different, you just choose to be relevant to things that are essentially detrimental to your own good. You guys are easily influenced by wrong, perspectives. Despite availability of all the resources in the world, especially for almost nothing, for free, guys. I mean, there were no YouTube videos of South African content on YouTube when I was a matriculant. There was none whatsoever. If you see some of the earliest videos of contents, they were like when, maybe 10 years ago. 10 years ago, I was already at varsity. In fact, I also never knew anything about YouTube or even the internet. The computers that were installed in my school in 2009, 2004, then we were promised we were going to be taught how to use those computers. They got stolen. Okay, maybe not all, but they stole most of them, such that it wasn't easy now to just take a class into the computer lab. So it was now on booking basis. So I remember some of my colleagues went. I didn't have the interest, so I didn't go. So I first touched a computer in the university's computer lab, and to my amazement, when I learned how to open that thing with my password, get in, Google came in. I started knowing how to search the internet, and my goal was also to know how to type. So I opened Microsoft Word and it worked. And that was it. By the time we had formal courses on these, guys, I was already flying. So a computer is a user-friendly device. I don't understand you guys failing with all these phones that you have, which are essentially mini computers in your hands. And worst of all, this exposes you to a whole wealth of knowledge that you should take seriously. I remember, guys, when I struggled with chemistry, I mean, we did what people do over 3 years in 1 year, in first year. We did the whole chemistry, including organic chemistry, which you would call it biochemistry, because at the time it had more applications to biological systems than just theoretical stuff. People do that for 3 years when they're doing a science degree. We did it in 1 year, guys, and nothing was taken away. That was hard. There were moments when things never made sense, especially when it came to geometry of these substances. Yes. That VSPER model, whatever you call it, guys. I'm surprised that you guys are learning this in grade 10, 11 or so already. We only touched it in at university, first year. Now, we had to draw almost like the exact geometry of those structures. We never had to just draw a line, 2D stuff. It had to be 3D, and even the angles, we needed to approximate them right. Yeah, that was a bit challenging, but once I started to understand that VESPR, I don't know, is it valence electron shell, VES, something. There's R though, I forgot the other ones. But it's a valence electron shell. Don't. Once I understood that thing, when you're talking about lone pairs and bonding pairs, I started to understand the forces involved that lead to those shapes, those trigonal, planar, orthogonal, tetrahedral and what. All of those things made sense when I had to go over the internet and check for some free websites from the US mainly. You would find mainly things from the US and some from, Britain, and then some from the East as well, but mainly it was the US stuff. But I found most of the US content more meaningful and easy to understand than you would find the British stuff. I don't know, the Brits have a tendency to just write things in a manner that doesn't make sense. If you don't have help, of course. You need someone before you can understand. But the US way of doing things, it's user-friendly. It's up to you if you want to go far or not. It's put in such a way that you can do self-study easily. So for those of you who want to really advance themselves, especially those who would be at university at this point, but perhaps some subscribers of this channel, I can tell you, try to look at US content for some of the subjects that you do. You will find yourself making it on your own. But again, yeah, things change as time goes. But yeah, I often find, even with my textbooks, I mean, if you get a neurosurgery textbook from the US and you take one from the Brits, I promise you, you will understand 80% of the work from the US textbook, but you will hardly understand even a quarter of a chapter if it is from Britain. I promise you guys, this is just something I don't understand, but maybe I'm too blunt anyway. I needed simple English because the US English is the simplest, sometimes to a point of being ridiculous, because it bends the rules of, the right English grammatically. But anyway, at this stage that I'm at right now, I can read any writing from anywhere and understand it perfectly because I put an effort, guys. When I find challenges with something, I push myself to the limits so that at least if I cannot reach the limits and be comfortable there, I'll at least be in the bracket of what is sufficient for me to proceed without any issues. So do that for yourself. You will be proud of yourself and you will get far in life. But remember, there are no freebies when it comes to accolades. You earn them. We can give you information for free. We can give you assistance for free, but you're going to have to earn the accolade. Even when you do earn the accolade, then there's a huge responsibility with the greatest accolade you can achieve. Unless you just want these to look nice and to flex on the social media, because I see a lot of people are flexing their degrees on social media, and I'm thinking, okay, it's good, it's motivating and all, but it's giving a wrong vibe in my opinion, because everybody thinks it's all about flexing those degrees. But I'm not seeing any improvement in terms of productions and functionalities that we expect from so many experts that we see. I mean, I see a lot of PhDs, guys. Every year you will see people are getting those PhDs. But if you look at their research, you read their theses, you realize there's nothing original that makes any sense. It sounds original because, I mean, it's never been done before, but it's ridiculous because it's common sense and common knowledge. So people are just doing academic exercises rather than, true innovations. Because remember, if you're doing a PhD, guys, it has to lead to some new developments in the subject. It can't just be an addition of meaningless and just ridiculous perspectives on anything at all. Even master's degree, guys, had to change how things work, at least if not at a local level, then at a regional level, and if better done, even at a national level. But PhD should even transcend the borders of a nation. It should be perfectly international and certainly impactful. But I see a lot of substandard achievements with these degrees. So you see, when you're wearing a red gown, guys, you cannot tell me that you're gonna just wear a red gown on African marriages. Of what use is that? What does it help us with? And now you will call you a doctor and you will claim to be an intellectual tomorrow, but you just wrote about African marriages. I mean, who cares about that? Who are you teaching, by the way? Because, we the Africans already are doing it that way anyway. Just because you're writing it to the world, so how does it change the world? Not at all. Yeah, maybe in indirect ways, you may sit down and say, okay, maybe how people from other nations then would start to deal with people of our nation, then they can find a way of knowing how to deal with us in the correct manner, I guess. But come on, guys, already when you don't know people, you treat them as fairly as possible. You approach them with care and caution, and you take their lead. You follow on their direction. So you don't need pre-knowledge for that. Not at all. But yeah, guys, we need to be serious about education. The education level we have in the country in terms of the system itself is 100% excellent. You can go anywhere in the world with our education and thrive, okay? The only thing that is lacking in our country is exposure to these technical factors. We do a lot in theory rather than practical because of poor management of funding, because these things need to be funded. And there's a lot of money in South Africa. Our government is just shameful, to be honest. But hey, what can we do? We created these monsters by praising mediocrity and touting them as intellectuals when they're just a loudest noise that makes no sense. In fact, it's irritatingly loud noise. That's what they stand for. And they are touted as intellectuals because why? They're acquiring these degrees, whatever means necessary, in whatever means necessary. And of course, we know they didn't write those degrees. They never wrote anything. They paid someone to do it for them. You can see in how they conduct themselves, man. There's no educated person who behaves like a hooligan. It just doesn't make sense. Yes, naturally, there are some people who are the exception to the status quo. They are just hooligans by nature, okay? I do have a component of that, but again, I choose moments to do that. For example, I would not be a hooligan at work when I'm faced with people who don't know me, but I can express my elements of hooliganism to those around me in my smaller circle, inner circle, because those people already understand how I do things, so they would not be reading wrong information about my hooliganism. But they already know what I stand for. But someone who has no idea what I stand for but has this presumed understanding of what I should be like, I would not show them my hooligan behavior, because then they would completely misread me. And of course, those who need to draw inspiration, I cannot show them my hooligan behavior because it will tell them that it's okay to be a hooligan. And remember, for a young mind, they put an effort in things that may be very dangerous. Okay, and they can easily get into those dangerous positions. Now we're seeing things that, I mean, guys, were not seen before because of not being careful in how we express ourselves in public. Yes, we're not pleasing anyone, but we have to be appropriate for the sake of the young minds that are looking up to us and for the sake of those who believe in what we stand for, but perhaps may not understand our hooligan behavior. Certain things need to be privatized. For example, I cannot show myself trending into the entire world, for example, just showing up at work with shorts and sandals or flops, if you call them. And then my hair is not combed, and I'm wearing a t-shirt and shorts, and I'm just doing ward rounds. I mean, what is that? I cannot trend that, but I can actually do it. Because when I'm only doing ward rounds, the patients in the ward that know me, because I've been their doctor throughout the week, for example, let's say it's a weekend, I was on duty the whole night, and I realized I have to go and do rounds in the morning. I mean, I can show up in my t-shirt, shorts, and sandals, because those people already know what I stand for. They know what is my worth in that setup. I can do that quickly and go home. But I would not wait until the families come to visit these guys and then here I show up on my shorts and stuff. Those people won't understand what kind of a doctor is this. And now if it happens tomorrow, someone dies while I'm operating them, they will say, no wonder that person died. You cannot trust such individuals. So the look sometimes can put you under some serious problems in the future. And people take this for granted. You will have no one standing with you because the image you painted of yourself is that of a person who's not really supposed to be allowed anywhere near individuals in this, So I'm just trying to say, folks, those who know me, they may be okay with seeing that, but I cannot show this to the world, and I cannot certainly trend it for public view. Take the doctor from Newcastle. I mean, people who know him, you can tell they are satisfied with his work. They are happy with what he stands for. But here's my problem with him. He put it on social media for everyone to see, that he can just come up with a radio at work and then he's dancing all around and all that. That looks nice and funny for the people who know him. It's fine. There's nothing wrong with that. But he cannot trend that for the world to see. Even the way he dresses, it's okay when he does it, under certain circumstances, again, on a small inner circle of his. But you cannot do that for the public's view to see that, because young minds think that's cool. And when they think that's cool, they're going to overdo it. But remember, they will not understand that before you did that, you actually are worthy to be in the position you are, because you stand for that position in all respects. But they won't know that because they don't know you. They just see you. You get it? So that's just my only issue with such individuals. Otherwise, those people are excellent. I mean, they're excellent individuals. They are within their own rights, of course, for self-expression. But remember, certain things are not about you. If you work for the public, guys, it's not about you as an individual. It's about all of us as a collective. Now, we cannot find ourselves represented by hooligans. We're just full-blown hooligans in public. That's just incorrect. Anyway, folks, I just preached, and I don't know why I did that. Of course, the video ended a long time ago, so for those of you who got tired of watching forever, you should already have stopped when I stopped the calculations. But I think sometimes, we improvise. The little time that we get with each other, we need to really reinforce each other's resolves so that we become better individuals rather than, whatever we can choose to be. Yes, we have that right, but we have to also realize that it's not about us as individuals, but it's about all of us as a collective. And if we continue thinking that way, guys, this country can be cured from all the ills that we see societally, professionally, and nationally, essentially. But if we continue to be individualistic in perspective, this country is going to go to the drain. I mean, down the drain. It's already close to the drain. If it's not already on the pipes down, God knows where. But hey, whatever happens, guys, it's your choice. You make that choice. But just don't cry about it. The likes of us are very comfortable where we are. Although we work under pressure all the time, we are happy with the pressure because it keeps us alive and with a reason to wake up every day with a goal to achieve. Okay. Anyway, guys, goodbye for now. We will meet each other in the next video. And for those who attend my classes, tonight at 7:30 or 19 hours 30, we're going to have a revision class. So please don't be late. We're using Google Meet. If you're already not in the WhatsApp group, I've already communicated that in the group, but if you're not in the group, please, there's my WhatsApp number on this channel. Just check the description of the channel itself. You will see there's my WhatsApp number, there's my email address. Either you email me or you WhatsApp me, but I think if you want to join the WhatsApp group, rather WhatsApp me so that I can add you to the group. And once you are in the group, you will have full access of information about our lessons, especially when there's cancellations or when there's changes to the schedule. And the advantages of being in the group, if you're practicing alone, you have a question that is burning, you just drop it on the WhatsApp group and we attack it like that. It can be me, it can be one of my former students who I regard as my colleagues at this point, or it can be any of your fellow matriculants, because some have exposure to better things, so they can assist. And then of course I always play the role of overseeing everything. Where I see something, I add. When I see a mistake, I correct. And that's it. Otherwise, guys, let's keep it going and we'll see how far it takes us. And I think this year you guys can really achieve a lot if you do your part and you do it well, consistently, diligently, and of course making sure, guys, that you do not take anything for granted. All right, guys, our 3 hours is over. I normally take 3 hours to do these reviews. I know I can take less than that, but I'm not here to show my skills. I'm here to show you the way, folks. That's just the intention of these videos, is for me to show you the way. That's why I take time, so that you can understand the sense behind what you see me do. Anyway, if you want this question paper, it's going to be in the description of this video down below, together with this memorandum. If you want it, it's going to be there. Hoping that when you combine this together with the video, you will get an understanding of what's going on. And if you've got any questions, there's a comment section down below. Drop it there. If you want to ask it privately, you've got my WhatsApp number on this channel. You can do so, or my email address. And if you want a clearer explanation, you can even enter into a small little class when I get a chance. Then I can take you through whatever may be the problem regarding either what I've done here or anything that you are probably faced with at the time. But remember, guys, my involvement in this is not for quick solutions. I see certain students in the group are not doing the right thing. You see them dropping questions, looking for answers and not looking for assistance in terms of understanding. That for me is a serious waste of time, because sometimes you find that the very questions the students are asking, there's already memorandums published for everyone to see. So this already tells you that if they can post a question like that, they don't understand something. But instead they want you to rewrite the answer, and they don't come to class, or they are not willing to join the class. Because when these questions come, they deserve to be discussed in a class where everybody can be on board and understand the very essence of what we are doing in answering those questions. Anyway, guys, goodbye for now. We will meet each other either in class tonight. Of course, maybe those of you who will be watching this video will be the next day. There will still be a video tomorrow. If you're watching this tomorrow, then it's gonna be tonight at 7:30. But yeah, the class for tomorrow or tonight, if you're watching it on the 28th, is going to be a physics revision. So we're gonna take a past exam paper, maybe the most recent 2025 paper. We're gonna take it from question 1 to the last, depending on how we are doing with time, of course. Tonight is going to be maths, and we're going to take it from the first to the last. Again, I will be modifying things to see that you understand, because this is revision. This is not wasting time. Okay, guys, goodbye. I'll see you then. Ciao.